Today we're going to talk about equations 1-5, lesson 1-5. Uh, we're going to learn how to solve, well, not learn, you guys have already learned this, but we're going to review how to solve equations with one variable. And we're going to also work with solving equations with two variables. But before we get started with that, who can remind me what an equation is? Anybody remember? What does it have in it? It has an equal sign. That's the key. That's the key difference between an equation and an expression. All right, it's the equal sign. So an expression had terms, variables, operations. The equation, you add the equal sign to those list of things. Go ahead and take a minute. You're going to have to get away with it right today, that I wasn't going to make you do this. Now, go ahead, take a minute, write down each of these words and find the definitions. We'll review them a little bit further as we go further in the lesson. But for now, don't have to do equation. I think you know what an equation is. Just remember that it has an equal sign. But solving means the answer. I can even go over these with you quickly if you're really paying attention. The solution is the answer. Solving means to find the value of the variable. Solution is the answer. Replacement set, element, solution set, and identity, I want you to go ahead and look up. I'll give you these again. So solving is finding the value of the variable, right, in an equation. And the solution is the answer. And if I'll give you a little break. Then if you'll look up these, that would be good. Watch your video and catch back up with me in a minute. Okay. So what we just talked about a second ago, right? An expression has a term, it has numbers, and it has operations. The equation has all of those things, plus it has the equal sign. Okay, finding a value for a variable that makes a sentence true, solving the open sentence. Oh, don't worry about that open sentence. So solving is finding the value for a variable. All right. A set of numbers from which replacements for a variable may be chosen is called the replacement set. So if you're given an expression like 3x plus 7 equals 13, and you're given a set of numbers, and a set of numbers, a collection of numbers, say our set of numbers is this. It's a random set of numbers. This is our replacement set. These are numbers that can be replaced, that can replace the variable. We could try 0, we could try 2, we could try 4, and we could try 5. And that is we're going to use all of those numbers to see which one can replace the variable. All right? To make the sentence true. The solution set will be the one which makes this statement true. So in this case, the solution set is 2, because 3 times 2 is 6 plus 7 is 13. So when x is 2, that is the solution. And again, and then each object in the set is called an element. So in this replacement set, we have 4 elements, 0, 2, 4, and 5. So here's an example. Find the solution set of the equation 2 cubed plus 5 equals 13. If the replacement set is 2, 3, 4, 5, and 6. So this is our replacement set right here. 2, 3, 4, 5, and 6. In this case, they put it into a table and looked at each one in the equation to see if it's a false statement. Well, will 2 work? 2 times 2 is 4 plus 5 does not equal 13. And then you try 3. Does that work? No, that doesn't. 4 work. 4 doesn't work. So what is the solution set going to be for this equation? That will be just one answer. All right, what I'd like you to do is I want you to practice making a table for both of these guided practices. 1A, so use this as your replacement. Place your variable with each of those numbers. See which of those statements is going to make it true. I'll be looking for tables tomorrow, so go ahead and make sure you make your table to figure out what your solution set's going to be. Pause the video, do your two tables, one for 1A and one for 1B, using that replacement set. All right. Solving equations. You often just use order of operations to solve your equations, and here's an example of how we'll do that. Solve 6 plus parentheses 5 squared minus 5 divided by 2 equals p. Okay, order of operations tells us we have to do our parentheses and our exponents first. So the first thing I'm going to do, of course, is write my equation on my paper. Divided by 2 equals p, right? All right, so inside my parentheses, I have an exponent. That's my first thing I'm going to do. 6 plus 5 squared is 25 minus 5 divided by 2. So next step will be to do my parentheses. Again, inside the parentheses, there'll be 6 plus, what's 25 minus 5? 20 divided by 2 equals p. What's my next step? Careful. Am I going to add 6 to 20? No, because I have to do division before I do addition and subtraction. Multiplication and division come before. So my next step is to divide 20 by 2, and I get 10 plus 6 equals p. So in fact, p equals 16. Careful with your order of operations. But pretty straightforward stuff, right, guys? It's just the same as solving as working with an expression. The only difference is we have an equal sign. And do remember to keep that equal sign pretty well lined up as you work down your page. All right, can you do guided practice problem number 2? And when we're talking about equations, some equations will have what they call a unique solution, meaning there's only one solution. Unique means one of a kind, right? So there's only one solution. Other equations we run across may not have any solution at all. Okay, here's an example of an equation with one solution. And we're going to solve this equation together. Okay, 7 minus parentheses 4 squared minus 10 plus n equals 10. All right. I think what I would like to do is do my exponents inside my parentheses first. So it'll be 7 minus 4 times 4 is 16 minus 10 and all right. 16 minus 10 is 6. So 7 minus 6 plus 10 equals 7 minus 6 is 1 plus n equals 2. Now we've got to move the 10 over to the other side, so we're going to subtract 1 from 8. We're down our n equals. Now the only solution that will work for this is 9. Some equations will not have any solution. They will have no solution. Let's look at this one right here. N parentheses 3 plus 2 plus 6 equals 5n plus 3. Let's see what we have here. Can we distribute? So we'd have n times 3 and n times 2. So we get 3n plus 2n plus 6 equals 5n plus minus 3. Can we go ahead and do that? All right, next step, 3n plus 2n would be 5n plus 6 equals 5n. look at this and think about the question. Equal 5n plus 7. Let's take one more step and look at this again. I get our n's together. Okay. So we'll put 5n, we're going to subtract 5n from both sides. So 5n cancel out. What do we have left? 6 ever equal 7? No. So there's no solution. And that's the mark you make to show no solution. Do you remember that? No solution. Here are two problems for you, 3A and 3B. Go ahead and work those two problems. And we will be doing these problems on the board in class tomorrow, or next time we meet. So be prepared to put them on the board. All right. Sorry about that. Skip one. Skip two. Oh, I just need to move these around a little bit. Sorry, guys. Okay. An equation that is true for every value of the variable is called an identity set. The equation is identical, okay? And what that means is that every answer will work. The two sides are identical. And here's an example of an equation like that. Okay, we have 2 times 5 minus 8 times 3h plus 6 equals Okay, that's a long equation, right, guys? Okay, let's work our way through it. Inside parentheses first. The 2 times 5 is 10 minus 8. Inside the parentheses, 2 10 minus 8 is 2 times 3h plus 6. You see that the two sides are identical. 3h plus 6 is the same as 2 times 3h. Any number, I'm going to put 8 quarter. We can even work it further. See that they're exactly the same equation on either side. So if I put, for instance, what if I put a 2 in for h? 3 times 2, 6 plus 6 is 12. I put a 2 in over here, we're going to get exactly the same answer. So in this case, all numbers in an identity set. Here are a few practice problems. Let's just do for a, well, let's do all of them. It's good practice. And we'll put these up on the board as well. Okay, let's write an equation to solve a word problem. So we've been just doing these equations. Let's look at a word problem and see if we can write our own equation for it. Mr. Hernandez pays $10 each month for a movie delivered by mail. He can also rent movies in the store for $1.50 per title. Write and solve an equation to find the total amount Mr. Hernandez spends this month if he rents 3 movies from the store. So he has his movies from the mail, his mail movies, plus he has his rental movies, store rental. How much does he pay each month? So it's $10, right? Plus pays $1.50. For how many movies did he rent? 3. And there's our equation. To figure out how much he spent this month. Put M for month. So we can calculate that out. 10 plus 3 times $1.50 is how much he spent on movies. So he spent $14. Okay. Here's a practice problem for you to do. Amelia drives an average of 65 miles per hour. Write and solve an equation to find the time it will take her to drive 36 miles. Can you remember the distance, rate, and travel? D equals RT. I'll give you that. Distance equals the rate times the time of travel. See if you can solve. See if you can write that equation. Okay, and I think that is it. When you finish this, that was a nice short video. Everybody should have good notes formed in more good practice problems, and I'll see you then.